the dimensions are 50 by 250. The area, if you put the 50 back into the area function, or if you multiplied 50 and 250, that would give you the maximum area is 12,500. Because remember, the function we typed in was the area function. Is that okay? Does it say? Okay, it doesn't say. Sketch a graph of the following functions. So these are your piecewise-defined functions. I would suggest until you get comfortable with these to use a pencil while actually drawing the graph of the function. Because the way I'm going to show you some erasing, or if anything, just draw lightly and fill it in darker when we're ready. So part A, f of x, just do f of x right now. F of x is 2x plus 3 when x is less than or equal to 0, and 4 when x is greater than 0. So a piecewise-defined function is a function made of, this might surprise you, pieces of other functions. Insane. I know. So what this notation says is the function is equal to 2x plus 3 only for the x's that are less than or equal to 0. Well, notice that's right here. X. Uh-oh. Are you mad at me again? What did I do? I sacrificed students. I mean, what? Did I say that out loud? So for only this portion of the graph, namely quadrants 2 and 3, we're going to draw the line 2x plus 3, or y equals 2x plus 3. What I suggest you do until you get comfortable is draw the entire thing and then erase what you don't want. So notice everything here is linear. So by saying 2x plus 3, that means the y-intercept is positive 3. And the slope says up to over 1. So if I connect these two dots, graph's a little off, but that's okay. It should have gone through negative 1.5, not negative 2.5. That's okay. But we do not want the x's that are greater than 0. We only want x less than or equal to 0. So which side do I erase? The right-hand side. Wow. Well, at least the delay is not as bad as the NBC Olympics. But now we have to worry about what happens at 0. Since there's an equal to sign here, do I put an open dot or a closed dot? Closed dot. That works. So the process is graph the whole thing if you want to, and then erase what you don't want. So notice this next portion is for x greater than 0. That's not supposed to be a triangle, that's supposed to be greater than 0. And we'll be graphing y equals 4. What does y equal 4 look like? Horizontal line. Again, if you already know how this is going to turn out, don't graph the whole thing, just graph it very lightly. But x equals 0 is the y-axis. Do we want the left-hand side or the right-hand side? We want the right-hand side, so let's get rid of the left. Gooey. But at x equals 0, we do not have an equal to sign, so what should I put there at x equals 0? An open dot, a hole. Since a piecewise-defined function is a function, it should pass the vertical line test. Does ours pass the vertical line test? Yep, we're good to go. As far as evaluating a piecewise-defined function, it all depends on what domain the x lays in. So if I said f of 5, would you pick the first function or the second function? If I said f of 5. Second one, because 5 fits this domain. X is greater than 0. So if I put in 5 in for x, what value do I get? 4. Trick question. There is no x because it's constant. So when x is 5, the y value is 4. But if I picked f of negative 1, you would pick the top function because negative 1 is less than or equal to 0. So you would say 2 times negative 1 plus 3, you'd get 1. So when you're asked to evaluate a piecewise function, you should only get one answer, otherwise it's not a function. If you would, please try part B. We have 3 parts there. I don't know, I feel inclined to tell you what that number is. It is negative 1/3, yep. So notice all the ones that they're talking about here are linear. They don't have to be linear. They could be any type of function. But linears are the easiest to graph. So the first one, negative 1/3 x minus 2, has a y-intercept at negative 2. And the slope says down 1 over 3. It should have 1 through negative 6, but close enough. We only want for the x values less than 2, which is right here. Here's x equals 2. Good enough. So we're going to erase everything that's to the right of x equals 2. And what happens at x equals 2? We put a what? Open circle. The next one says when x equals 2, y equals 3. What is that going to look like? Yeah, just the point, 2, 3. If we were given a range of values there, like from 2 to 5, it would look like a horizontal line segment. And lastly, y equals x. What does y equals x look like? Yeah, what's its name? It's a very specific line. Rhymes with my identity. It's your identity function. Very good. It's the one that bisects the first and third quadrants. I'm not going to draw the whole thing because I don't want to erase everything. But we only want it for x greater than 2, which means to the right of 2. What happens at x equals 2? Good enough.